So we can make it distinct here, or we can make it distinct here. So what it's doing is animals2.stream.distinct.collect, collectors to map. So we've already taken out any duplicates. So we can use this stream of strings as a key because we no longer have duplicates. And then its value is going to be the length of each string. So everyone get that so far? Yeah? Okay. Now, so one simple way to ensure that your key, if it's an integer, to ensure that it's going to be unique is to have this guy as a static int, okay? Now, I created a variable called, it's down here, static int count is equal to 0, okay? So that means that's what the value is going to be at the very start of our program, okay? So we have map integer string, integer map is equal to animals, so it takes in, so this is the key, this is the value, okay? So coming based on animals2, which is a list of strings, so this is a stream of strings, okay? So collectors to map, so it takes in a string, doesn't do anything with the string, but what happens is it returns plus count. So that means then it takes in a string and returns a string. So this stream here has got 7 strings in it, okay? So the values are going to be the keys are going to be 1, 2, 3, 4, 5, 6, 7. And they're going to correspond to the items on the animals2 list. What are the items on the animals2 list? We have dog, cat, mouse, cow, sheep, pig, ox. Actually, we have 8, and elephant. Okay, so that's one simple way of ensuring that your hash map is not going to have duplicate values. Another simple way is if you are connected to what is called a normalized database, okay? Fully normalized database. Now, databases contain something called a primary key. So your database is made up of rows. So database is made up of rows. And it's going to have fields in it such as name, address, age, occupation, etc., etc. Now, it's going to have a unique identifier. For instance, a PPS number. Everyone has a unique PPS number, okay? Now, your PPS number is what identifies you, okay? Now, a PPS number is a primary key. They have to be unique. So, another example of a primary key is a car registration. Carriage. Another is an air, right? So, is an air code a unique identifier? You know the air codes? Right. Is an air code a unique identifier? No, it's not. Apartment blocks all have the same air code. So it's not a unique identifier.
I think it could be considered like unique because it's rounding up, like, you know what I mean? Like,
Well, right, so.
Not each house, but.
Yeah, right, so it uniquely identifies a building, but it doesn't uniquely identify a residence.
Depends what you're looking for.
No, right, so. No, but I know people who live in apartments. and there's 4 or 5 apartments, they all have the same.
But how's that different?
Yeah, but I know, but it doesn't, your residence, there could be several different apartments in an apartment block. So it depends what you're identifying. If you're identifying buildings, yes. If you're identifying residences, no. Okay, it has to be used in conjunction with the number as usage. All right, so by itself, it doesn't identify a residence. It identifies a building, but it doesn't identify a residence. So if you're doing databases, whenever we get fucking Azure, we probably will be doing something that's going to have addresses in it. We probably will be doing something that's going to have an air code in it. So we'll have to take into account apartments and buildings. So a unique residence is going to be a combination of the air code plus the apartment number. Okay? So we're going to have to devise a unique identifier for every residence. Okay? Now, if you know that your database contains unique values for each record, they can be used as a key in a hash map. All right? So that's another simple way. So you're relying on some other technology to do it for you. All right? You connect up to a database, you get all of the PPS numbers, you assign them as the keys in your hash map. It could be key in a hash map that uses the PPS to identify a person that's created from all the fields in a table in a database, name, address, age, occupation. You could create a human object from those 1, 2, 3, 4 attributes, which are going to correspond to attributes of an object. So you have a map of a unique identifier, which is a PPS number, which is going to be a string, and a human object. Okay, we will be doing that when we come to databases. Right, so here you're going to end up with, let's do it here. So it's this one here. 1 dog, 2 cat, 3 mouse, 4 cow, 5 sheep, 6 pig, 7 pig. Okay, now that's using the second list, which is this guy up here. Now we're not using those for the keys, we're using those for the values. Okay, we're using those for the values. So what are we using for the keys? We're using just an external counter, which is a static int. It goes plus plus count. And the values are just going to be the strings that are contained within this string. Okay. Now, the second overloaded to map function, it takes, so first thing calculates the key. The second argument calculates the value. And it also takes a binary operator. Now, so this to map function doesn't work if you have duplicate values or if you have duplicate keys. If you're trying to create something and it has duplicate keys, it's going to generate an illegal argument exception. This one here, this will take duplicate keys, because what happens is if you have duplicate keys, do whatever we say here in binary operation. So this calculates, the key, this calculates the value. This will only come into operation if we have 2 keys the same. All right, so function takes an object, returns an object. Function takes an object, returns an object. Binary operation takes 2 objects of the same type and returns an object of the same type. Okay, that's what a binary operator does. Let's go down the screen. So now, doesn't matter what you call the variable. All right, I call this k because this guy is used to calculate the key, but this is still a stream. Okay, this is still a stream. Right. Now, this is still a stream. So animals.stream, that produces a stream of strings. Okay. Now, our key is going to be, so animals, int map. Okay. This takes, int map takes an integer and a string. Okay. So that's that guy there. So int map is an integer and a string. So animals.stream, so we're basing it on a stream of strings. Okay, so the key is going to be the length of the string. Now we have stuff like dog, cat, cow. Okay, they all have the same length. So they will have all the same key. Okay, so we do have duplicates in this. So we do have duplicate keys in this hash map. Okay, that guy there. So dog has a key of 3. Cat has a key of 3. Cow has a key of 3. Pig has a key of 3. All right. So we have duplicate keys. Now, the value. So V is as a string. Takes in the string, it returns the string. So the value is going to be wherever the string is. So the key is going to be the length of the string. The value is going to be the string. So we do end up with duplicates. For instance, 3. Okay. The key value 3 applies to dog, cat, cow, and pig. So if we have duplicate keys, what are we going to do? We're going to take in the strings and we're going to concatenate. Okay, S1 and S2, so binary operator. It takes in 2 what? It takes in 2 strings. Okay, takes in 2 strings. So we start off with dog. See that the key for dog is 3. The value for us is dog. So we end up with 3 dog. There is no duplicates. We then go on to cat. And we see that cat also has a key of 3. Okay. So we have a conundrum here. What do we do? This guy kicks in. Okay. This guy kicks in. It takes in dog. It takes in cat. And it concatenates them to 1 key. Now what it does, or to 1 value, it takes in the first string, puts a comma in between it, and then puts in the second string. So we end up with dog, cat. Okay. Next thing, it sees cow. It sees cow also has a key of 3. That's the value. So what it does, S1 is now that guy. That's what S1 is. S2 is cow. So it concatenates cow onto that. So we end up with dog, cat, cow, and it does the same for pig. Okay. So that's what's going to happen. All right. So we end up with so we have 2 ox, 3 dog, cat, cow, pig, 5 mouse, sheep, 8 elephant. Okay. So the first type of 2 map method takes 2 functions. That can't deal with duplicate keys. The second overloaded method takes a function, and a binary operator. this can deal with duplicate keys. What it does is concatenates the values for each duplicate keys. So this guy here ends up with 3 dog, cat, cow, pig, 5 mouse, sheep, 8 elephant. Yes? Okay.
The binary operator has to return something. Can you do anything you want to say? Like, could you remove the element?
No, the binary operator, sure, it takes 2 and returns. So it takes 2 integers.
Yeah, it has to return something.
No, binary operator just takes 2.
Oh,
Yeah. Oh no, no worries. Binary operator, sorry. Binary operator takes 2 objects and it returns an object. It doesn't have to be the same object. It has to return a string. Why does it have to return a string? Because int map is integer and string.
but I could do anything I wanted inside that. I could
Can, of
remove
course.
the object.
You can return null, yeah.
Yeah.
You can do anything inside any of these.
Yeah.
As long as it returns an object. Ideally, should return a string, but it can return null.
So you could delete duplicates.
Yeah, so, but it has to return either null or a string. Just like that one has to return string or a null. Just like that one has to return an integer or null. Why? Because int map is integer string. That's the beauty of functional programming. You don't have to define things. It knows things. Okay? It knows that this guy here is a string, K is a string, V is a string, S1 and S2 is a string. Is that okay? Right. No. This is the time to ask the questions. Right, sir. So, int map. This is what int map is. Now, int map consists of an integer and a string. Okay? Now, that's what int map. Now, did I clear it just to make sure? I think I did. I did. Int map.clear, right? So, this is an empty hash map. Okay? Now, so it's going to be based on animals. Now, what is animals? Animals is, I'll make sure I have the right guy. Second overloaded. So I'm going to write them all out. So we'll go up to here. So where's animals? Oh, where the fuck are you? That's animals 2. So it's, there it is. Okay, so I'll write them all out. So we have dog. Now, streams are kind of, how can I put it? If you never did programming before, they're easier to learn. If you have done programming before, they're going to be harder to learn because they're an alternative to loops. They're an alternative to, they are an alternative to loops. Okay, so dog, cat, mouse, cow, sheep, pig, ox, and elephant. Right, so that's our list, okay? Now, let's scroll down the screen. So this is the one, okay? Right, so now animals.stream, that produces a stream of strings. That guy, okay? So we'll call this stream A. Okay, stream A is going to produce a stream of 1, 2, 3, 4, 5, 6, 7, 8 strings. Yes? Right. Now, so collect operates on that stream of strings. Okay? So we have collectors to map. So what it's going to do is going to take this stream of strings. This is a terminal operation. So this is the operation that actually creates your stream of strings. All right, so to map, that means it's going to use all of these strings to create hash map. All right, now this is the to map function, or the to map method that takes 3 objects. Okay, this guy is a function. This guy is a function. This guy is a binary operator. Now, so a function takes an object, returns an object. They don't have to be the same type of object. Next one is a function takes an object, returns an object. They don't have to be the same type of object. Now, binary takes 2 objects and returns an object of the same type. Okay? So that's what those 3 things are. Now, so to map. So we'll start off with this guy here, k.length. All right? Now, I'm going to rewrite that particular one. Okay? I'm going to rewrite k.length. Okay? So here's I'm going to rewrite it. Just need to erase stuff here because I got too much on the screen. All right, so first argument is going to be, I'm going to say string k. I'm going to erase that. I'm going to put double or curly brackets around this guy. Right. Now, so what's happening here is that it's taking in each string in the stream. Okay? It's taking in each string in the stream. So it's taking in dog. And what's it returning? It's returning the length of that string, which is going to be 3. So it's taking in cat, and then it returns the length of that string. It's taking in mouse, and then it's returning the length of that string. It's taking in cow, and then it's returning the length of that string. It's taking in sheep, and then it's returning the length of that string. It's taking in pig, and then it's returning the length of that string. It's taking in ox, and then it's returning the length of that string. It's taking in elephant, and then it's returning the length of that string. So that guy there returns 3, 3, 5, 3, 5, 3, 2, 8. It's going through each one of the strings, and it's returning the length of the string. Now, int map is an integer key and a string value. The first argument in this to map is for calculating the key. So it goes through each one of the strings in the stream, and it creates keys. It creates 8 key, 1, 2, 3, 4, 5, 6, 7, 8. Okay, it creates 8 ints from each one of these guys. Okay, so instead of having a loop going through it, this does it all automatically for you. Okay, so that is a longer version of that sort of thing there. Now the next one. Now I called it K here because I want to say it's key. I call it V here because that's a value. Okay, so this one here can be rewritten. I'm going to get rid of everything. Okay. So I'm going to rewrite this. I can say string V, and I put curly brackets around this lad. And this is return V. Okay, so and I put on the same level as this. Right. So what this does is this is for calculating the value. Okay, so it takes in each one of the strings in the stream and it returns that as a value. So it takes in dog, it returns dog. It takes in cat, returns cat. It takes in mouse, returns mouse. It takes in cow, returns cow. It takes in sheep, returns sheep. It takes in pig, returns pig. It takes in ox, returns ox. It takes in elephant, returns elephant. All right, and at the end of that, what you end up with is 3 dog, 3 cat, 5 mouse, 3 cow, 5 sheep, 3 pig, 2 ox, 8 elephant. Okay, now this method, what it does is if you're not allowed duplicate values in a map or duplicate keys in a map, okay? So you're not allowed duplicate keys in a map. So what's happening here is, so binary operator, it takes, sorry, a by function. Okay, this is a by function. It calls a binary operator, but it's a by function. A by function is it returns 2 objects, it returns an object. In this case, they're all the same type. Okay, it doesn't have to return the same type, but in this case, it does return the same type. So what it does is, if, so we have 3 dog, all right? Now, there is, next one is 3 cat. So it sees that it has, so it sees that it's got the same key. So S1 is dog, S2 is cat. So what does it do? It concatenates the 2 of them. Okay, so you end up with 3 dog, and I have the little comma there, cat. And it provisionally saves S1 as that. Okay, next one, mouse, is fine. It goes to cow. Okay, so cow has 3. So what it does is S1 is that. It concatenates it with S2, which is going to be that guy, and concatenates the 2 of them, so we end up with 3 dog, cat, cow. Does that explain it, Igor? Yeah. Yeah. So you can see how it's difficult to do with loops. Yeah. Yeah. So it is. Now, I said something before about how they quickly create things. That's not strictly speaking true. Okay? Yeah.
All the K, V, and the space.
Mhm.
So they're all strings.
Yep.
Because, and those space and
Exactly. Yeah. Yeah.
always, so they always have to be the same.
In that case, yeah.
In that case,
Yeah. So now you can go along and actually give them values as I've done here. Right? See here? But you don't have to. But just for clarity, I put them in there. Okay? You don't have to give, that's the longer form of the lambda. All right? Thing about that is, if you start doing that for everything, you're going to quickly end up with something that looks complicated. All right? So try and get used of using.
parameters in the body function are going to be whatever state it's made of.
Yep. Yeah. So whatever it's made of, and what is it going to return? So int map, remember, is an integer and a string. Okay. So it has to return a string, which is that what that is. Okay. Now, as you said, Igor, to try and even accomplish that with loops, you'd be all freaking day trying to accomplish it, right? It's very easy to spend hours doing that. Something very, very simple that should only take 5 minutes. That literally takes 5 minutes to do, not even 5 minutes. All right, so it's a massive time saving. So I said before that it quickly creates objects. Is it quicker for creating objects than for loops? It depends. Huh?
I don't think it is. Because
Probably isn't.
it could create a bazillion.
It
before
could,
takes
yeah.
lightning.
It could create a bazillion, yeah, as you said, Jason. But with modern servers, a bazillion isn't that hard to do. Okay. Now, there is techniques you can use to decrease the amount of objects that are being created. All right. So, does it create objects quicker? That's very, very debatable. Probably doesn't. But you're still talking about nanoseconds here. All right. And that's a hell of a lot easier to program than try to do that shit with loops. I don't even want to think about it. All right. So it's just easier. It's a lot easier to manage. Yes, it is a bit of a leap to go from loops to doing this. If you never did loops, and this is how you learn programming, it'd be a bitch to learn loops after only doing these. It should be easier to learn these after doing loops. Do you understand what I'm saying? Loops are more difficult than these. There's no doubt about it. Loops are much more difficult than these guys. Okay? It's funny how you learn loops as a part of basic programming, but they're much more difficult than these guys. All right? This is a case of event stuff is actually easier. Okay? These are actually way easier than loops. You don't even have to think about them half the time. You just do it. Now, that's the second overloaded to map function. The third overloaded to map function. So they all just build up on, so this is, so it takes a function. Now, this is a, so it's a binary operator, okay? Now, binary operator is, it takes in two objects, it returns an object of the same type, okay? A by function is something different. A by function is it takes in two objects, it returns an object, they don't have to be the same type. Do we all understand that? Okay, so this is a binary. A binary is it takes in two objects, returns an object of the same type. Whereas a by function takes in two objects, returns an object. They can be all different objects. They can be all the same. Okay, so this is for calculating the key. This is for calculating the value. This is for this is what we'll do if we've got duplicate keys. The last argument is a supplier. Okay, it's supplier with the type of collection object we want. Okay, it's supplier with the collection object, so we can have a particular collection object. So instead of having a map, we have a tree map. And we did this previously up further where we created a tree map and then we took the contents of the map created and just added them to a tree map. Here, we can create the tree map in one go. All right. This is taking the length as the key. This is taking the string as the value. This is going to concatenate the strings if it's got the same key. And it's going to put them all into one tree map. So then it's going to organize them by key. So you end up with 2 ox, 3 dog, cat, cow, pig, 5 mouse, sheep, 8 elephant. Okay. Again, to try to accomplish that by using loops is, oh, fuck me. Actually, that wouldn't be a bad assignment. Do that with a loop. All right. I don't even want to begin to think how to do it. It'll take a lot of planning to do. Okay. So, funny thing about streams is the more complicated they become, the more advantages you can see.
Last option there was, you said it's supplier.
Yeah, it's a supplier. Okay, so here's a different version up here. So I'll just comment out that guy, and I put in this guy. So it's returning a new tree map made up of integers and strings. Okay, now you see, here's the beauty as well of the shortcut. So if you use this version, you have to say what type is going to be here. Okay, if you use this version, you don't have to say what type it is because it knows it's going to be an integer and a string. Okay, whereas if you use the longer form, you have to specify the type. If you use the shorter form, you don't have to specify the type. It knows the type because it gets it from here. Okay, so what does this do? This will produce the following, which is this guy. So 2 ox, 3 cow, pig. So this sorts the hash map, the map by key. Okay, so 2 ox, 3 dog, cat, cow, pig, 5 mouse, sheep, 8 elephant. Okay, now so why are they doing so much with collectors to blah blah, all this sort of things? Now, because this is all leading into no SQL. All right, we don't do no SQL. I don't know how to use no SQL. All right, but what I do know is that all these techniques we've been doing since we came back, they all can be applied to no SQL. All right, no SQL is you have no database connected. You have no database. All right. Instead, you use raw programming power to do all your work. And they're going to be using streams. They're going to be using collections. All right. You would have a folder with 1 million different documents of different types in it. So you create a stream of file objects. Some of these file objects are going to be pictures. You filter them. You want to get all the pictures inside your folder. You would go file objects dot stream dot filter. It would produce, you would get only the pictures. You will get only the video files. You will get only the Word documents. You would get only the PowerPoint files. And then you would only get, you would link it up. You do another filter that would link up to your AI that would recognize only the pictures of cats. Okay, so just to quickly write it out, you would have something called file objects. Okay, now, and so that's going to be a all your objects inside your folder. Okay, there's a million of them. So file objects, that's stream. That's going to produce a million file objects, all different types. Then we go dot filter, and we only want to get, let's say, pictures. Okay, that will just get you the pictures. Then you go dot filter, and inside here you connect to your Azure AI, and you use your Azure AI to check for pictures of cats. And that's it. That will search a million files and return only the pictures.
Assistant contact reception. General assistant contact reception. Thank you.
So you have file objects dot stream dot filter for pictures only. Dot filter check for pictures of cats. Now that will require an AI, but you do whenever we get fucking Azure. It's quite simple. You just put in a method call. You put in a call here to the Azure AI that has been trained to look for cats, and it will produce your pictures of cats. And if you want to filter that down further to only brown cats, all right, that's NoSQL. That's how it works. Okay. If we ever get it, I don't know how to do this, but I know that's basically how it works. Be interesting just to see it. If you have any sort of image recognition apps, I have one here for wine, bottles of wine. I think everyone knows that one. Do you know that one? Where you take a picture of, or you put your phone up to a bottle of wine and it recognizes the bottle of wine. Huh? Google Lens is another one, actually, yeah. So they're all working on, they connect up to an AI, but it's going to be something like that. Okay. If you're trying to accomplish that with loops, oh, Jesus Christ. All right. You just file objects.stream.filter. You just only the ones with file extensions, JPEG, PNG. You would have a list of them and you just filter out for those ones that contain in this list. And then you'd filter out by connecting to an AI, and that would check for cats. So that's how easy it is to do it. Okay. That's the beauty of it. It is relatively easy to use, particularly if you have streams. If you're using ordinary programming techniques, a lot harder. It's a lot easier using these guys. Okay. Now, so as I say, we'll have streams finished today, but we won't have it finished before lunch, obviously enough. Okay. So the next one, this is going to be static void EX8.
Martin Noon, contact extension 277. Ivan Gannon, Martin Noon, contact extension 277. Thank you.
Right. So I'm going to create a list, strings, and I'm going to call it animals, and it's going to be equal to these lads. Right. Now, so we're going to be creating streams from this. Now, we could have created a stream directly from these, but it's always easier to create a stream from a list because you can keep using it over and over again. Do we understand that? If I did this instead, string strem is equal to stream of. If I did that, each time I do an operation on the stream, I'd have to recreate it each time. Do you understand that? So it's easier to use a list and base your stream on the list because you can keep using it over and over. Okay? Now, so what we're going to do here is an extension of what we're doing there. This is grouping by. Now, so what this does is, so returns a group of lists, but it's actually collection objects. That are grouped in whatever format we want. Okay, here we are going to return lists of strings, and the first list will contain all the strings with 3 characters in it. Second list will be the list with 5 characters in it. Okay, because dog, cat, cow, and pig all have 3 characters in it. Mouse and sheep have 5 characters in it. So this is going to return 2 lists. And how are we going to group the list? We're going to group the lists by the lengths of the strings. Now this can be anything. You can group them by weight. You can group them by sex. You can group them by county. You can group them by occupation. You can group them by age. Okay, so the metric we're going to use here is the length of the strings. Okay, so now this produces a map, okay, of integers and lists of strings. Okay, key 3 will be the list that contains dog, cat, cow, pig. Key 5 will be the list that contains mouse and sheep. Now, so I am going to go the easiest ways to show you. So I'm going to create a map of integers. That's going to be the key. The value is going to be a list of strings. Okay, and I'm going to call it T map list. All right, so what is this guy? This is a map of integer keys and values, which are each a list of strings. Okay, so we're going to say it's equal to, I am going to go animals dot string dot collect. Now I'm going to go collectors dot grouping by. So we're going to group it by, so this is, so we're based on animals dot stream. So that's a stream of strings. So it takes, grouping by takes in a function. Okay, takes in a function. So it takes in whatever type the stream is here. So it takes in a stream. Okay, and it returns dot length. Now, so dot length is going to be the key. Okay, dot length is going to be the key, and what that does is it looks through your list for all strings that have got the same length. Okay, so it sees that dog has a length of 3, cat has a length of 3, cow has a length of 3, pig is a length of 3. So you're going to end up with one list which is going to have, it's going to be identified by the key 3, and that's going to have a list of dog, cat, cow, and pig. We're going to have another one. This one has got 5, mouse. Okay. So key 5 is going to be a list that contains mouse and sheep. Let's say elephant. Is there any other animal you can think of that's got 8 letters in it? Elephant and no. Seagull is 6. Fuck it.
Antelope.
Huh?
Antelope.
Antelope. A-N-T-E-L-O-P-E. Manual, thank you. Yeah. Oof. Yeah. You're right. Okay. So we just have 2, right? So we're going to have one list that's going to contain elephant and antelope. We're going to have another list that contains dog, cat, cow, sheep. And we're going to have another list that contains mouse and sheep. Yes? Okay, so key 3, and this one here, key 8 will be the list that contains elephant and antelope. Okay. Now, so if I just go to print off this list, okay, so this is a hash map, okay. Now, this is a map of integer keys, and its values is a list of strings. So it produces, when I go to print it off, this is what it looks like. Okay, I need to go to here, main. All right, so 3, dog, cat, cow, pig. 5, mouse, sheep. 8, elephant, antelope. So you can see what it's producing. It's producing a map that contains integer key and a value. Each of the values is going to be a list of strings. All right. Now, let's say I want to get just the first list. First, let's say I want to get this list here. Okay. So what this gets, this prints out everything. Exactly this. Now we can see this is a map that contains, that's the key. That whole lead is the value. That's the key, and that's the value. That's the key, well, that's the value. Yeah? Yes? Right. Now, let's say I want to get just this one. Okay. Now, if I do that, I go tmap list dot get. So I want to get the list that contains dog, cat, cow, and pig. Dog, cat, cow, and pig. Okay. I want to get the one that contains mouse and sheep. Change that to 5. I want to get the one that gets the elephant and antelope. Now, so what is that? That is going to be, that's going to get that guy. So go here. That's that. This guy here gets that. And this guy here gets that. Now let's say we want to get an individual dog. We want to get the dog, or we want to get the sheep. Okay. Now this is a list of strings. So let's say I want to get the dog. Okay. So this gets the dog. And we go like this. tmap list dot get. We're going to get the list with the key of 3. And we're going to get the first object in that list, which is a dog. Okay. I want to get the last animal that has, right. We don't know how many, let's just say we did some image processing, all right? And we don't know how many letters have got 8 characters in them, okay? But we want to get the last letter in it. How would we do it? So I'll say that again. We don't know how many animals with 8 letters in it are there, okay? It could be 1,000, there could be 4, there could be 1,000,000, all right? But I want to get the last, in this case, I want to get antelope. Now, exactly, size minus 1, okay? So, ooh, hold on. That might fucking work. Actually, let me just see. So I'm going to try and get the inflow. This gets the antelope. Yeah, I don't think that's going to work. So tmap dot list dot get 3 dot get int index. Now we'd have to get the size of that guy outside of it. Okay, I'd have to go int size is equal to tmap list dot get 8. Dot size. Okay, so that's going to get us the size of that list, which is going to be 2. And then I'd have to say, I can say it here, minus 1. Okay, so that means that's going to be 1. So we just go, no, there's so get 8, right? Oh yeah, sorry, shit, yeah, sorry. Get 8 dot get size. That should get us the last, that should get us antelope. Fingers crossed. Yeah. Now, that's a hell of a lot easier to do than fucking loops. To do something like that with loops would be a fucking nightmare. Right? I don't even begin to know how you do it. All right. So this gets the last item. Huh? You could use a deck, yeah. Yeah, that's one way of doing it, yeah. We could and get the last item of the deck. That is true. We could, yeah. Okay. Again, yeah.
Would you not put in the right-hand side of the line above it? Or is that?
Say that again now. What line?
Yeah,
There.
Yeah, instead of size, so you have to size the find out size.
What?
I have it inside.
You've put it inside here.
Yeah. It's just instead of.
Oh yeah, instead of -1 there. You mean?
Just give inside equal to what's on right hand side.
Yeah.
So when you come to the line 1960, put what's on right hand side instead of size there.
You could, yeah. You could, yeah. Yeah, so you could. Yeah, so you could say dot, could put it in here. Yeah, I've probably done something wrong there now, have I? Do I?
Yeah, one more. Curly bracket. Yeah, there you go.
No. So we have T-map that's close bracket. Close bracket.
Sorry, inside the dot.
Oh yeah. It needs to be a bracket around that. That produces a number, and then you put a bracket.
You see how you have T-map list dot get 8.
Yeah.
Instead of the 8, you want T-map list dot get 8 dot size -1.
That size -1 is.
Yeah.
Yeah. Fuck it. Size inside here. No.
No, inside the 8. So delete the dot size there.
Yeah.
And then instead of the 8, you have another T-map dot list dot get size -1.
T-map list.
T-map list, yeah. Dot size -1.
Size -1.
Yeah,
Yeah, I wouldn't. I wouldn't do that. No. I definitely wouldn't do that. No. That's too fucking messy. All right.
Other back there. Plus T-map.
Where?
See after the string, we have plus T-map list first T.
Yeah. And yeah, well, that all in. Yeah,
Sorry.
Now, do you know what? I wouldn't fucking do that. I definitely would not fucking do that. All right? No fucking way would I do that.
You just add.
Yeah, I know. It's going to give you the same answer. It's getting me null though.
No. See, if you just add the 8 again after that first
Here, yeah.
Yeah. So add some more brackets with an 8 and then dot get.
So bracket.
Yeah. You want to get inside again.
8
Dot get.
dot get. Take out this guy. So it's gonna get me.
That's what you had originally,
Yeah.
Inside.
Then you go T-map list dot get.
Dot size.
Oh no, definitely would do that. Dot size -1. Oh Jesus, no.
Yeah.
Oh fuck no. No. No fucking way would I have that. So no. No, I would take that out. Fuck that. So I would take that guy out entirely. And I would put in this letter. Now, if you want to do it the other way, fine. I prefer using that way. Yeah, it's a lot easier to see. Okay. So T-map, so that gets the list that is of size 8 and get size. Now, if you want to get lunch, I advise you to go now. Okay. So I will stop. I will stop the recording.